Have you ever wondered how the internet just knows everything? You know, your entire shopping history, your wish list, that half-full shopping cart from last week? Well, today we're pulling back the curtain on the technology that makes it all happen, databases. We're going to break down how all that information gets stored, organized, and, most importantly, made super useful. So let's start with a question. Just think about your favorite online store for a second. How on earth does it know who you are, what you bought a year ago, and whether that brand new phone is in stock, all in the blink of an eye? And spoiler alert, it's not magic. It's a really well-organized database, pretty much the unsung hero of our entire digital world. All right, here's our game plan for today. We're going to start with why we even have this modern data problem. Then we'll introduce databases as the solution. We'll dive into how they're built, see how all the pieces connect, and finally, learn about the language we use to actually talk to them, which is called SQL. So let's kick things off with the challenge. We are living in a sea of information. I mean, every click, every purchase, every like and share, it all generates a digital footprint. For businesses, this isn't just random noise, it's a gold mine. But trying to manage this massive, constantly growing ocean of data, that is a huge, huge task. Let's go right back to that online store. It's not just dealing with one simple list of things. Oh no, it's juggling all of this stuff, all at the same time, for potentially millions of people. You've got product details, customer profiles, inventory levels that are changing every single second, order histories. It's this complex web of information that has to be lightning fast, 100% accurate, and totally reliable. A simple spreadsheet would just completely fall apart. And that, right there, is where databases come in to save the day. They are the elegant, really powerful solution that's designed specifically to bring some order to all of this data chaos. At its very core, a database is just an organized collection of data. But the key words, the ones you really want to pay attention to, are organized and efficient. See, it's not just some digital filing cabinet where you dump stuff. It's a highly sophisticated system that's purpose-built to handle incredible amounts of information without even breaking a sweat. The best way to think about it is like a super-powered Excel workbook. I mean, Excel is a fantastic tool, we all use it, but it starts to really slow down once you get into the thousands of rows. A database, on the other hand, is engineered to handle millions or even billions of records and still be incredibly fast. But it's not just about speed. Databases make sure the data is reliable and consistent, we call that data integrity, and they can handle tons of people accessing the data at the exact same time, something a spreadsheet just can't do safely. Now, not all databases are the same. You've got different types designed for different jobs. There are these flexible NoSQL databases that are perfect for handling messy, unstructured data. Think social media feeds. Then you have these massive data warehouses built for really deep analysis. But the true workhorse, the one that runs the business world, is the relational database. And that's exactly where we're going to focus our attention. So why are we zeroing in on them? Well, check this out. Over 70% of all enterprise data, the data that actually runs businesses big and small, is stored in relational databases. So if you want to understand the language of business data, you've got to understand this technology. It's that simple. Okay, so how do these things actually work under the hood? It might sound really complex, but I promise you, the core ideas are surprisingly simple and logical. It all starts with something we're all familiar with, the humble table. And here we go. This is the basic building block of a relational database, a table. I mean, it looks just like a spreadsheet, doesn't it? You've got your columns for things like name and email, and you've got your rows, where each row represents one single thing, in this case, one customer. The golden rule here is that each table stores data about one and only one specific type of thing. So let's lock in some of this lingo so we're all on the same page. We've got the table, the row, and the column, which we just saw. The schema, you can think of that as the master blueprint for the whole database. And then we have two incredibly important concepts, the primary key and the foreign key. These two are the secret sauce that gives a relational database all of its power. Okay, now for the really cool part. Let's see how these pieces all connect. This is where the relational in relational database really comes into play. It's all about how we link these separate tables together to tell a much bigger story. You can think of it like a secret handshake between the tables. And that secret handshake is done using these keys. A primary key is a totally unique ID for each and every row within its own table. No two rows can ever have the same one. Think of it like a unique ID number for a student. A foreign key, on the other hand, is basically a copy of that primary key that's stored in a different table. And that's what creates the link. It's how an orders table knows exactly which customer placed which order.
So if we look at our customers table, that customer ID is the primary key. Rahul is customer number 1, Priya is number 2. It's simple, it's unique, and there's absolutely no confusion.
Now, here's where the magic happens. Look over at the orders table. It has its own primary key, that's order ID, but look closely. It also has a customer ID column. That's our foreign key. We can instantly see that orders 101 and 102 were placed by customer number 1. And because we have that link, we can look back at our customers table and know that customer number 1 is Rahul. Boom! The connection is made. And these relationships built on keys can form a few different kinds of connections. A one-to-many relationship is exactly what we just saw. One customer can have many orders. You also have one-to-one relationships, and even more complex many-to-many relationships. But they're all built on this same really elegant idea of using keys to link tables.
Okay, so we figured out how the data is stored and connected. But, having an organized library is pretty useless if you can't actually ask the librarian for a book. So how do we communicate with the database to get information out? For that, we need a special language.
And that language is SQL, which stands for Structured Query Language. Now, please don't let the term programming language intimidate you. It's really more like a very precise, very powerful way of asking questions to get exactly the answers you need from your data. Now, SQL is a pretty versatile language. You can see it has commands for basically everything, from building the database itself to controlling who gets to see what. But for anyone whose job it is to find insights and tell stories with data, one of these categories stands out as way more important than all the others.
And here is the absolute key takeaway. As a data analyst, your world is going to revolve around the select statement. That's the part of SQL that's all about querying, about asking questions. See, your job isn't to be the architect who builds the library. Your job is to be the skilled detective who knows exactly how to find the information hidden inside.
All right, let's do a super quick recap of the essentials. Databases bring structure to total chaos. Relational databases use tables that are linked together. That link is made with primary keys, which are unique IDs, and foreign keys, which create the actual connection. And finally, we use the language SQL, specifically the select statement, to ask questions and get answers from this whole organized system. And that kind of brings us to a final thought. Now that you've had a peek behind the curtain and you see how all this data is structured and connected, it changes how you look at it, right? It's not just a chaotic mess of information anymore. It's a library where every single piece of data is carefully cataloged and linked. So the real question is, what would you ask? What secrets would you want your data to reveal?